Hello, welcome back to another exciting Mr. Davies Neighborhood. Today we are talking about science, in particular, the structure of matter. So the first question you might have is, what is matter? Well, family matters to Steve Urkel. You don't get that. But matter is what makes up everything. Everything has matter. Everything you see, you are matter. And matter is always moving. Always. It might look like the wall you're staring at or the computer screen is being still, but it is not. It is moving. So next time you're sitting around all day and your parents say, hey, you haven't done anything all day, you can say, yes I have, because I'm made up of matter and I'm always moving. I'm sure they'll love that. So now, matter is made up of what we call atoms. All right? And this is where we get more into the structure of matter. All of matter is made up of atoms that is constantly moving. Now there are parts of the atom that you need to know. So inside the atom, you have what is called the nucleus. That's basically just the brain of the atom. And it is made up of two different things. One of them is called the proton. The proton is just positively charged particle, is all it is. So, positive. See how the P and the P go together? There you go. Proton, positive. The other part that makes up the nucleus is called the neutron. The neutron is just a neutral charge, or no charge. And these combined make up the nucleus, which is just the brain of the atom. Now, there is a third part that you need to know, called the electron. So if the proton is positively charged, the neutron is neutral, no charge, what do you think the electron is? It's negative. So proton positive, neutron neutral or no charge, electron is negative. A lot of people get this confused because they think negative and they think neutron. That is not the case. The electron is negative. And all of these, so if you're looking at an atom, it sort of looks like this. So I'm going to color code it for you. So if I have 3 protons, got our neutrons. Then outside of this, we have our electrons. Now, as you can see, I have 3 protons in the middle. I will always have the same number of protons in the nucleus as I have electrons outside. These are just the outer rings where the electron circles around the nucleus. It's exactly like what the moon does with the Earth. It just circles around it, right? Because as they say, opposites attract. So the positive and the negative are attracted to each other. So it just circles around itself. So this is basically what the atom looks like. So what you need to know is the proton and the neutron. These two right here, they have equal mass. And the proton and the neutron, there's the same number of protons and electrons in an atom. So if there's 3 protons, there's going to be 3 electrons. So now we move on to the phases of matter. Plasma, which is the one people usually forget about, is usually found in stars or lightning bolts. It's also actually found when a capsule comes back from outer space, which is a spaceship, when they're coming back to the atmosphere, and you see how that fire come off of it. That's actually plasma. All right. Now the other three phases are solid, liquid, and gas. All right. So we start with plasma, solid, liquid, gas. Now the most common example of this you see, and the one we're about to talk about, is water. All right? Water, when it's frozen, becomes what? That is correct. It becomes ice. All right? So ice is a solid. What that means is all the particles are, or all the atoms are very, very close together. All they do is just vibrate around. All right? What you need to know about this is it has a fixed volume, shape, and mass. Sorry about my terrible writing. Sort of looks good enough, right? All right. So, and this is an important idea of what I'm about to tell you. So, to change phases of matter, you need one of two things. You need temperature or pressure. That is how you switch from a change in matter, whether it's adding it or taking it away. So if I increase the temperature of an ice cube, what happens? It melts and becomes water. So we're going this way. So I'm going to write melts, or melting. And this is a liquid. And what you need to know about a liquid is it has a fixed mass and volume, but its shape varies. And that makes sense because liquid takes the shape of whatever you put it in, such as I have my water bottle here. Do you think that water that I poured into it was that shape when I put it in? No, it takes the shape of whatever you put it in. So that's what it means when it varies shape. All right? So now we're just going to stick with temperature because how do we change it from one phase to another? We add or take away temperature or pressure. So then we move on. Boiling. So when you take water and you boil it, it becomes a gas. That's my attempt at showing you boiling. It's not the greatest, but it'll do for now. So we started with ice, and then we melted it because we added temperature, and it became water. Then we added more temperature, and it boiled. And with a gas, you have a mass that is fixed, but its shape and volume vary. And that makes sense because gas takes the shape of whatever it's in also. All right. Well, that's it for the structure of matter and the phases of matter. I hope this helped you out.